Hello everyone, today we will talk a little bit about shaders in Unity, and we will leverage shader graph to create, for example, this Moba Style HP Bar of the player, which you can see here. And it actually works like you expect on many MOBA games, for example, or StarCraft has a similar health bar where each chunk is basically 100 HP. So when I at the right side increase the HP to 1000, then he has 10 chunks, and if I remove it, lower it to 900, then we have 9 chunks. And we can increase the health and decrease it, and it works properly like we want to. This is a rather complex shader, even though it looks really easy. So we start with 2 little effects just to get into shader graph, and then we will create this health bar shader, which is a little bit more complex. So when I start the game, then I can show you 2 of the skill effects we will have later in the game. I'm currently trying to get skills and everything working with the backend, and I'm currently working on that. So the next video we will be able to attack some flowers and get them in our inventory and basically be able to farm something in our game. But for this video we need to prepare some visual flair. So let me deactivate the UI. I didn't start the backend because I didn't need it. So on the left side here we have a little lightning bolt, and we are able to fire a lightning bolt like that. So there will be lightning skill when a player attacks, and this lightning bolt will appear and attack the flowers. On the other side we made a little fireball which will start around here at the top and will attack the player and has an impact animation also. Let me show you that again. So maybe even remove the player and remove the canvas and shoot the fireball. So we will start doing those shaders which are needed for the effects, and then we will talk a little bit about the particle system, but I want to keep the particle system portion really short in this video because we want to talk about shaders. Maybe we do a bigger particle system video later, but for now let's talk about shaders. I have developed multiple shaders to work with those. If we leverage the lightning bolt, it basically has all the shaders. It leverages all the shaders that we have, which one time if you start with shaders and you want to have this bloom effect in the particle system, when you set a color, the color can't have an intensity, so you don't have an HDR color. It is basically just a simple color. But what we can do, we can in our shader set an HDR color. So when we go to, for example, the bolt itself, when we go here, I have an HDR color which is just for the intensity basically. So when I lower the intensity, you see it isn't glowing anymore, and if I increase it again, we have this bloom effect again. I don't know which value it was. That's how this works. Let me turn to my state. Yes. So that's how this works, and let's check out the shader to make something bloom. Like this glare here is basically just a sphere. You could take the particle which is 2D, but the sphere is easier, and we make this particle glow. It's glow textured here, but we don't have a texture selected, so we could make this particle glow. Should be the same, and the bottom one is particle glow. So let's look at the shader real fast. It's the simplest I have. We have this particle glow shader. Let's recreate it. step by step, so you get used to creating those shaders. First of all, right click, create shader, universal render pipeline, because we're leveraging it. Unlit shader, we don't want to have lightning interfere with this. With a lit shader you have normal map and everything available, but we don't need that. So let's take particle glow 2 and open it up. First of all, on the right side you can configure some settings with the whole shader or with nodes when you click something. And for the whole shader, the first thing we want to do is we want to make it transparent, so that we can modify the alpha value, and then we can also change the blend. When I go to opaque again, alpha is missing and we want alpha. Like I said, in a particle system we can't have an HDR color, but in a shader we can. And when we add a color to it, HDR color, then we can set it on mode, on the left side on node settings to HDR. Make it white and maybe give it a 6 on intensity to have it per default some values. Those properties, if they are exposed, can be modified by the material. So we want this color basically combined with the color of what is configured in the particle system, and the particle system gives this color into the vertex color. So we basically want to multiply. I just drag and then I can have the search window and be able to search something, or you can right click, create node and add something. So let's multiply those together and put it into base color. Since when the vertex color has some alpha values, we want to leverage them as alpha values. So we split the color of the color from the shader, from the particle system, and we put that as alpha in our fragment shader. And this is basically it. This allows your your particles to glow. So when I go to the materials, my particles have materials, and the bold flash, it's using already the glow 2 because I tried it out. Before that it was particle glow, so it was this one, and we can test out. It works. And now let's change that to our new shader again, which is particle glow 2, and it should work the same. Great. That's how one of the simplest shader works, but this shader gives us the ability to have this glow effect. When you, for example, take the default particle, then it's just a color with some alpha values in that case. But you won't be able to leverage the bloom effect to give the lightning bolt, or in this case the impact and starting of the lightning bolt, this bloom effect, and we leverage a shader to do that. The next one is the bolt shader, which is a little bit more complex but not too much. So let's go into that one and let's open that up for reference, and let's just create one to show what is going on. The reference is just for me to take a look if I miss something and later compare, but actually I might not even need it, to be honest. So let's again do the particle bolt 2. It's an unlit shader again, it's transparent again, and same thing, we want an HDR color because also the lightning bolt should be able to have this leverage the bloom effect. So basically the same deal. We have the vertex color, we multiply them again, put them as color, we split out the alpha value and put it in alpha. So the next thing we want to have for this shader, we want to have a texture. So let's add a texture to the bold texture. Let's just call it texture. And let's drag that in, and maybe for default I select my bold. Where is it? There it is. So how did I create the image? Quite simple. Affinity Designer. Let's go to drawing. I've drawn a line, a curve like that. Just clicked and drawn. I copied the line and gave the other one a Gaussian blur effect. Let's just add a black pixel layer, so then you can see better. So I created this line and copied it over. So Control C, Control V, and gave it a Gaussian blur effect to make it blur. Nothing more than that. The reason why we want to have this blur effect is later in the shader we will configure the thickness of the bold, basically how much white is in the image. So the middle one is basically seen all the time, and we will move the transparency away so that the bold gets thicker. There's a trick to do that really good. So let's first of all take this texture and sample it. What this takes, it takes the UV coordinates, in this case UV 0, which for normal particles is 0, 0 top left and 1, 1 top right, bottom right. And let's add this to our color here. So we multiply again, and then put that in our color. So, and for alpha, we also multiply that with the alpha we have and put that into alpha. Then we have our image. So next thing we want to do is basically controlling the thickness of how fat the lightning bolt is. There's a really easy trick to do that. Let me just reorganize that a little bit. Just multiply the vertex and then split out the alpha and put the alpha in there. Doesn't change much, but it's just for simplicity for myself. So like I said, we will control the thickness. So let's just add a float for now, thickness, and give it a value of 0.5. And we add a step function and we use the thickness as an edge. And put this in here and put this in here. And now we can modify the thickness, and at the bottom right you can see the bigger the value, the less thick the bolt is, and the lower the value, the thicker the bolt gets. And for 0 we should only see basically white, which is not true. The alpha is white, so black comes through. So how does this work? The step function actually is quite easy if you understand it correctly. Let me give you an example. Let me add 2 floats. And with shaders, if you don't understand something, it's always really good to make those examples. So we have an edge, and basically this edge tells us when a value goes to 1 or to 0. So when I have the edge as 0.1, 0.5, and when I add the value 0 to it, the image will stay black. When I add the value 0.5 to it, the image will go white. And if I add 1 or anything bigger than 0.5, the image will get white. So everything above this edge will be white, so will be 1, and everything below this edge will be 0. And that's how the step function works. And with the thickness, we basically, for the color values R, G, B, and A, everything that is below a certain threshold is 0, so it's not shown, and everything above this threshold is shown. And since we have a blur effect on the edge of our lightning bolt, this blur effect basically gives values from 0 to 1. And if we higher the edge, if we increase the edge, then this blur effect will get removed part by part. And if we lower the value, more of the blur effect shines through. We don't use the blur effect in the image to make an actual blur on display. We just make it to control the thickness of the lightning bolt. That's how this works. We will we will use the step function a lot today to make such distinguishes, to make such math happening in the shader really efficient, because an if clause in a shader is really inefficient. What we also want to do, we want this lightning bolt to move in the y direction. So let's do that real fast. It goes always the same. That's actually really easy. We add a float, and this is basically the speed, and we multiply that by time. So there's a time node, we get the time, we multiply this each other, maybe speed is 2, and then there is this tiling and offset. This node looks way more complicated than it really is. UV coordinates, like I said, in a particle is 0, 0 top left and 1, 1 bottom right. And what we can do with tiling is, instead of making it from 0, 0 to 1, 1, make it 0 to 2 or 0 to 5. With x2 then it's 0 to 2, and with x5 it's 0 to 5 in the x direction, and the same goes in the y direction. What it does internally, it takes the UV coordinate and multiplies it with, basically, if you have tiling 2 here, then it multiplies the x with the 2. And y with 1, and this is basically ignored. Like you can see, the image looks the same now. When I take 5 and x, then it's 5, and when I take 5 and y also. That's what tiling does. And if you make a texture wrapping around, then if the UV coordinate goes above 1 in one direction, then it will come back from the other side. So basically 1.5 is again in the middle of the image. I hope you understood that. And the same goes with offset, but offset on the other side is not multiply, but it's addition. So when we have vector 4 and we add here stuff again, then we can say we have 5, 5, and we can say the offset maybe 1.5. then it moves a little bit. And again, when I do that, the same thing in my little mask thing, the same thing happens to the UV coordinate. So this basically, this tiling and offset is a short variant of a multiply and addition being able to do to the UV coordinates. So, and basically what we do with speed multiplied by time is a value which increases over time. We can create a vector 2 out of that, and maybe we want to put that in the y coordinate and put that into offset and make this 1 and 1 again. What this does now is x doesn't move at all, the offset is still 0, but this number is increasing over time and everything will move over time now. When I put now the new UV coordinates inside here, then you can see that the image is scrolling from top to bottom all the time, which is the effect we want to have in our lightning bolt. The only thing now missing is being able to control the thickness in the particle system. It's easy to do if you know what you're doing, but it's kind of hard to explain, honestly. What you can do in a particle system is you can create other UV coordinates and give it to the shader, which is the simplest way to do that. So let's say we take UV1, which here displays the wrong values because the values will come from our shader, from our particle system. So we take UV1 and we just need one value, so we split it up and take the R value from it instead of the thickness. So we can remove that, and this is our shader, and the thickness is the UV1 we will use in our particle system. Let's compare it. Speed multiplied by time, tiling offset, sample texture with the scrolling UV coordinate. As an edge we have UV1 with the R, same. And we have the typical glow stuff which we started with, and we add it all together. So here I multiply. Here I split it up and multiplied, which should be more performant. So let's do that, because it just multiplies one value instead of multiplying the whole vector. But it shouldn't change too much in the output. So we have particle bolt 2. Let's check out when we go to the material for this bolt, and let's pick our new shader which we created together, and hopefully it still looks the same. Yes, it does. So like I said, the thickness is controlled by the particle system. Let me really fast explain that, because this is crucial for shader and writing shaders for particle system. You often want to have a curve or something which gives value to the shader. First of all, you have to go to the renderer, and then here you have to do custom vertex streams. When you start out, it looks like that. It's position, normal, color, and UV. We don't even need the normal. We could, but it's fine. That's the default. The thing we wanted to add is another UV coordinate, which in this case is UV2. This basically fills up the text chord XY and ZW. If we don't do that, then the next value we add, let's say we add speed, then it will be in text chord. So we basically fill up everything for the UV coordinates for the shader. So text coord 0, x, y, and zw are UV coordinates. And the next one, when we fill something up, which we do, is a custom x value, so one custom value. And this one custom value goes to text coord 1.x. And in our shader, text coord 1.x is a UV, is the UV1. This is text coord 1, and we took the x part. RGBA is the same as x, y, z, w. So the R is the same as the x, and that's how this works. So we have to fill this up to not, because we don't care. What we also could do, remove that because we don't need it, and we have text coord Z, but like the error said at the bottom, this doesn't work out. It doesn't let you do that. So we fill this up with some garbage values, and then we add our one value to the x coordinate for the UV1 in the shader. At the top, we have the ability, let me collapse everything here. We have the ability to give custom data, and our custom one is a vector, but only with one component. So we have just x, and I added this little curve to it, which controls the thickness of the bolt. Let me, for example, move everything down. Now the bolt is always visible. And the same, like we showed in our shader, when the thickness goes to 1, then the edge is moving and everything will get transparent eventually. And if the thickness is lower, then the edge is moving and more of the bolt is shown. That's how everything here works. And when we are here, let's really fast go over this whole particle system really fast. I deactivated shape. Normally shape is activated. I deactivated it, so it's always just spawned in the center of so every particle is spawned in the center of the particle system. And then I went to the renderer and set the pivot to 0.5. The default is 0. Then it's the particle spawns in the middle of, or is rendered in the middle of the particle system, but I want the bolt to be upwards, so 0.5 moves the pivot to the bottom, so it moves the bolt up. After that, I gave it a size of 3 and did minimize the X size of 0.4, gave it a color, and make emission burst count 1, so just one particle is at the beginning of the particle emitted, and this is the bolt we see. That's how this works. Now let's go over to the rather complex shader, which is this Healthbar. There are multiple ways to do the shader. Honestly, this one has a little issue. It's a sprite unlit shader in this case. Healthbar 2. The issue with that one, you might see it, the first and the last box are a little bit smaller than the other boxes. The reason for that is that I draw the boxes and then I draw the border on top of it. What you can do is you can remove the border from the shader and just create another sprite below the Healthbar and make the border that way. But I think this is fine. We can later fix that. So first of all, we have the border. Let's start with that. Or first of all, right click in the main preview and do a quad, because that's basically what we have. The only difference we have here in our shader than in the real world example here is that the quad, the width and the height of the quad is the same in the shader here, but in our real example it's not, because we want a pretty long Healthbar and not a square one. So first of all, let's start with a border color. border color. And that's a pretty simple color, and black is fine for me. Like I said, with the UV coordinates, or let me explain my thinking process. I want to have a border on the outside of the quad, and I can leverage UV coordinates to get the position where I am in the shader, in the position of the quad. And what we can do now is split those up, and so we can process X and Y parameters by themselves. Then we need a vector2 border size. The reason why the border size we need X and Y and we don't have one float value for the border size is because we will not have a square at the end. The border size is different for the Y coordinate than it is for the X coordinate, which is not nice, but it's handleable because the Healthbar doesn't change in size. You configure it one time correct. Because if you think about it, it's the UV coordinate basically is a percentile where you are on the quad that we are rendering. And if we have a height of 50 and have a width of 100, then if you count it pixel wise, for example, we want to have a 10 pixel border, then for the X coordinate, which is 100, we need 10%. So after 0.5 we have 10 pixels reached, but in the height, when it's only 50, then we reach 10 pixels in 0.05, so it's faster because it's the percentile. And that's the issue that we are facing when configuring this, but this is configured one time, and there are ways to fix that, but they're way more complicated, and I didn't want it to make the shader more complicated than needed. So we take the size, we split it up again because we always need it split, and then we take the step function again. So when we take the UV coordinates and we cut out everything that is below than, for example, our threshold, then we got a little border. Let me show it to you. We have the border size, which is 0.1, and we take the UV coordinates, then everything is cut off till our edge threshold. So this is one edge done in our border. And let's take another one and do it with the Y and the Y coordinate. And then we have the bottom one done. And then you hopefully will understand that 0 is not top left, it's bottom left of the UV coordinates. But that doesn't change what we do a lot. So when we multiply them together, a 0 multiplied by a 0 multiplied by anything is 0, and a 1 multiplied by 1 is equal 1, and we got this little half bottom left border done. So what we can do now is leverage something which is 1 minus. It does exactly what it tells you. It takes 1 minus the value. So when our value is 0.1, then this is 0.9. And if we do the same thing again with the step function, then you see we have the right border. And we do that again. It's the y coordinate minus this one. This is step in. This is the edge again. This is the edge and this is the in. They were the other way around. What you can do, you can switch them, then you get what we have seen here. So let's do it like that. And we can turn this around again with 1 minus, and that's what we do. Then we multiply them again to combine them, and we do the same with those two. We multiply them again and we get this border. Let's put that into our color. So we have our border, and like I said, sadly, this, depending on how you look at it, we need to configure that correctly, but we will do that later. So we want to have our border color, so we 1 minus this again, multiply that with our border color, and add this to our screen, which is just black because we don't have the filling. So this is one part. The next part is to have something like a progress bar, which is quite simple. We have two colors. One color is our health color. Let's make this green. And one color is basically empty or non-health color, doesn't matter. I took a float, not the color. Let's put color in the name so we understand the shader later also. Let's make this gray. And then we have two floats, which is the current health, and we have another float, which is max health. So let's put max health to 1000 and current health to 250. So let's first calculate how much percent is each of the colors, which is quite simple to do. Health divided by max health is basically how much percent is full of health. So we can take our UV coordinates again and take the X portion. We split them, take the X portion into a step function again as an in value, and if we take this as an edge, then we see the right side is health that is missing, and if we 1 minus that, the left side is the health that is available. So when we take health and empty, multiply them with the appropriate part, here. I mean the health color, not health, sorry. And we can combine them again with a multiply. Oh, sorry, with an add, because 0 plus green is green and 0 plus gray is gray. And we have this mask already, so let's use that. Then we have this Healthbar. And the more I think about it, the more I think that the border is a bad idea. Let's remove the border. For now, because the border also cuts off a little bit of the health at the left side. So sorry for throwing up the process. So, but how do we make those splitters in the middle? There's actually quite easy trick to do that. Let's just first remove the border. We do that with the UI later. So we first of all we have a health splitter value. So when does a splitter happen? And let's say most games say every 100 HP there is a health splitter. So let's first calculate how many splitters there are. This is really easy. Max health division by health splitter. Let me zoom in. Max health division by health splitter. So 1000 division by 100 means 10. So now we again use the tiling and offset of the UV coordinate, and we multiply that basically by the value of how many splitters we want to have, and then we do some mathematic trick. So we want a vector 2, and this is x coordinate, and the y coordinate is 1. So tiling offset, so this basically goes from 0 to 10 now. And the one trick is if we do this modulo by 1, then now everything goes from 0, 1, 0, 1, 0, 1, 0, 1, and that 10 times. Now when we want to have a splitter size, then we can take the splitter size. Let's say we want to have it 0.1 and multiply. Step edge does this to that, then let me just get the x value. Let's do that here. We just get the x value and then we edge it. Then you can see we can increase or decrease the splitter size. Let's take 0.2. And easy enough. Multiply that with our health and put it in the base color. So now this is working. Maybe you want to give this another color, then basically you can 1- again to have a mask that is the other mask of this one. Then you can create a splitter color. Color, multiply those again. Maybe configure a color for, let's take something reasonable. Maybe a red, which will look ugly as hell. And then you have those splitters there. Let's make the splitter color black. So one issue we have is that we have this edge on the left side, but we don't have this edge on the right side. which looks ugly, but there's actually quite easy trick. We can just move the coordinates here a little bit, and we know exactly how much they have to move. So we multiply this by -1, so we get negative splitter size, and we divide it by 2. So negative half the splitter size is exactly what I want. Vertex to x and y0 is basically the offset. Oh, sorry, it's the splitter size, half the splitter size. Now the left and right part is the same size, which makes it easier in the UI to configure the health bar in the middle. So another issue now, which you will see when I just give us 500 max health, is that the splitter size increases, which is not what we want. The reason for that is that this mask that we create here, like I said before with the square, this is the UV coordinate is percentile, and if we multiply it by 5, the percentage moves basically. But that's actually quite easy to do, because we know how many splitters we have, and there's a linear correlation on how much the size increases by splitter, the splitter size increases depending on how many of splitters we have. So what we can do to fix that, so that we don't have to configure the splitter size again, what I mean basically is, let's say I have 200, then the splitter is this size, and if I have 400, then the splitter is actually half as big as it was for 200. So this is the linear correlation that we have. And what we can do is multiply the splitter size with the amount of splitters that we have, and use that. Now with 200, the splitter size is like this, and with 400 it's the same, but our splitter size is too big. Let's increase it, decrease it. So the splitter size is like that, and even if it's 400, it's still like that, and if it's 800, it's still the same thickness. So this is basically our health bar shader. The problem is when I use this shader now here in our material, let's just do that real fast. Health bar, it's health bar 2. Where is the shader graph? Health bar 2. Then this is working, but the splitter size is quite huge. Something like that. But the border is now gone. And also I have forgotten something. So you can see, since we multiply the splitter size now, the left one is bigger than the right one, because we didn't multiply the splitter size here. To make this even again, we also multiply here the splitter size so that it moves correctly. Now left and right are basically the same. What we can do now is to give this a border, which is the way I will go, is create a sprite, or basically just copy copy this one. Yeah, I knew this was an issue. So we have this Healthbar, and then we work here. Healthbar is just black, so it's default. Universal render pipeline unlit. I picked the wrong one. Universal render pipeline, sprite 2D, sprite lit. Isn't there a sprite unlit? Let's just add a sprite, a square, and make it black. Move it up. Give it an order of -1 so it renders in the back. So 1.5, 3. Just move it up with the Healthbar inside. Use our shader obviously. Make it beautiful. That's default material, Healthbar material. So why do I see another Healthbar here? Oh, it's because in my scene there is this Healthbar. So we have this now, and with the border as its own element is actually easier to handle. Border. Because then each chunk has the right size. So, and then you don't have to fiddle around because this is pixel. And this is how we did our 3 shaders. We have a Healthbar now. Let me actually clean that up again. So delete the 2 that we just created. And for the Healthbar shader, we will use the one we just created to fix this issue. Great, let me just check if lighting bulb and everything isn't working anymore because the material used the wrong shader. And glow. Yes. This one is also particle glow, and the bold shader bar of bold. And so this is particle glow. This is particle glow. So if we hit play, everything should work. Maybe fix the player. Check out if the Healthbar works. So when he has 500, it's half full. If he just have 800, this looks fine. Lightning bolt looks fine. And firewall also looks fine. Great. So this is it for today. We have this cool Healthbar and these two cool effects, and we will make its own video with more effects like that about a particle system where we will configure more complex particles. But next video definitely will be having props like flowers, being able to cast some fireballs and electro spells at them and get something in our inventory when we kill them. I really want to thank my patron Julian for supporting this project and wish you all a great weekend. Bye.